something. Anyway, you get these big numbers, these big, even bigger numbers here. Look at these huge numbers, right? It takes a lot of storage. Dragging these x's along, there's a big drag on memory. I mean, this is not the way to, this is why we do numerical computation. But what the Babylonian algorithm, in the absence of any roundoff, is equivalent to computing, above the line, it's computing the square root here, and then below here, these are the iterates towards the derivative. So it's not actually calculating x, 1/2 x to the minus a half. It's actually doing something iterative that is approximating 1/2 x to the minus a half. All right, well, let me tell you now. Let me sort of reveal what's going on, just so that I can kind of show you how it's getting the answer. And like I said, it was the SVD that sort of convinced me how this was happening, because the SVD is also an iterative algorithm like this Babylonian square root. But it's easier to show you the point with the Babylonian square root. So I'm going to do something that I would never want to do, which is explicitly write a derivative Babylonian algorithm. And what I'm doing is I'm going to take the derivative with respect to x of every line of my code. So, if every even or odd line, I never know what's even or odd anymore, but the original line of code had 1 over 2. Now I'm going to take the derivative. I'll get a half. Here I had this line of code. If I take the derivative, I'll use the quotient rule, and this would be the derivative. If I run this code, what I'm effectively doing is I'm just using good old plus and times and divide, nothing fancy. There's not a square root to be seen. But what I'm doing is, as I run my algorithm, I'm also I'm actually computing the derivative as I go. So if I have this infinite algorithm that's going to converge to the square roots, the derivative algorithm will converge to the derivative of the square roots. But I'm not using anything other than plus, minus, times, and divide to make that happen. So if you rewrite